I'll show you how to optimize the wehnelt setting, the emission current setting, using a picoammeter. In this case we'll be using the RBD 9103, but you can use your own picoammeter with bias box as well. So the first thing that we've done is when the electron gun was first turned on, we went ahead and warmed up the filament. That's always a little dialog box that will pop up and open for you, and recommend that you warm up the filament, which I always recommend you do that when you first open up the electron gun. It takes about 5 minutes to warm up the filament and stabilize, and the filament can sit there for 5 or 10 minutes and then everything will be thermally stable. So my filament is on because it stayed on after the warm-up routine. I'll go ahead and turn on my beam voltage to 2 kV. We should see the emission current pop up a little bit, and there we are. So it's actually starting to stabilize because this is close to the operating point for this filament. So let's talk a little bit about the electron gun and the wehnelt and how that all works. So first of all, the filament is made out of tungsten, and what we do is we heat it with DC current. We heat the filament up hot enough to where it can emit electrons from the tip of the filament. Then the wehnelt lens is basically a small cylinder that fits on top of the filament with a little hole in it, and by applying a slightly negative voltage, we're able to repel the electrons down towards the tip to where only the electrons that come off the tip escape. The other electrons are suppressed. So the higher the wehnelt voltage, the greater the suppression, the smaller the spot size. Of course, if you increase the wehnelt too high, then you're going to totally choke off the beam. So what the purpose of optimizing the wehnelt is to try and get the best, the smallest possible spot coming off the filament with the highest amount of current going to the target. So here we see the filament, the electrons are leaving the filament, the wehnelt is suppressing it. We're trying to get it small enough to go through the anode aperture. The anode aperture is a small aperture that helps to shape the beam and make the size of the beam small. And then once it gets through the anode, the electron beam gets focused by an objective lens down to the specimen, where we're trying to get the smallest possible spot size. Alright, so let's go ahead and measure the target current. By the way, with the 9103, you're going to want to always turn the 9103 on first and then open actual. And what that will do is, if you have settings like, for instance, the bias voltage is applied and the target is grounded when you're not measuring current, it'll remember those settings. Otherwise, if you open actual first and then turn on the 9103, it may not remember those settings. And so you always want to measure the target current with the plus 90 volt bias applied, and when you're not measuring target current, you want the target to be grounded. Alright, so we're close to the operating point. We want to be about 300 nanoamps of target current. I'll go ahead and reduce my filament current a little bit, so I'm a little bit below 300, and now I'll adjust my wehnelt voltage, and you can go up or you can go down, but the main thing is you want to change the wehnelt voltage, which basically suppresses the electrons either more or less, while monitoring the target current. So let's try increasing the wehnelt a little bit. Okay, I'm increasing the wehnelt and the target current is going down. So now I will lower the wehnelt and the target current's going up. So let's keep lowering it until we can find that peak. Current's still going up as I lower my wehnelt. Slowing down there, now it's dropping. You see that? So I'm going to go up a little bit more with the wehnelt until it starts dropping again. There we go. So pretty close to this point here. 37.3 gives me 327 nanoamps. That's a little bit high. But I'm going to go ahead and hit set point. What that does, it will set my 2 kV wehnelt voltage to where it's optimized. Okay, now what I'll do is I'll go ahead and reduce my filament current. This is coarse, this is fine. I'll reduce the filament current a little bit until I can get close to that 300 nanoamps, and I'll hit set point, and I'll say yes. Okay, so now we have the set point set. The wehnelt voltage is optimized, and we're set correctly for 2 kV. Now I want to do the same thing with 3 kV. So let's run the voltage up to 3 kV. Remember, the filament's been warmed up for some time. You always want to have it warmed up because otherwise, if it's cold, you're going to get a different result. See, I'm lowering the wehnelt voltage now, And the target current's coming back up. And there it goes down. Let's peek that up again. Right there. So I'll say set point again. Yes. See, now I'm setting the set point for 3 kV. Yes. So now we have the set point, the wehnelt voltage is optimized for both 2 kV and 3 kV. If I go to 2 kV, then the current should be approximately still 300 nanoamps. And if I go up to 3 kV, that slope is going to change, and so the emission current's going to, the target current's going to stay fairly constant all the way up to the 3 kV value. So now it's optimized for both 2 kV and 3 kV, the wehnelt voltage. If sometimes the filaments are not exactly the same target current at 2 kV and 3 kV, if that's the case, you want to set the filament operating current while at 3 kV, because you're going to be taking, most of your data is going to be taken at 3 kV as well on the electron beam. Okay, so that's how that works. I'll go back down to 2 kV. And remember, you can set this often. You can if you're not sure if it's optimized, just go ahead and click it up a little bit or down. Say, okay, that's dropping. Let's go the other way. That's dropping. Okay, I changed it a little bit. Now I hit set point. It says yes. See, the value is slightly different than what I had before, but pretty close. Okay, yes. So you should check the wehnelt optimization often. Anytime you're operating the electron gun, if you're not sure, it's so easy to check it. Just go ahead and increase or decrease the wehnelt voltage a little bit until you optimize your target current. And then when you do that, hit set point. And the same thing with the filament current. If your filament current is a little bit high, say right here, I'm a little bit too much, 345 nanoamps. Let's drop that filament current down a little bit. Okay, close to 300. And set point. Yes, look at that, same exact value. Yes. Alright, stop sampling. And that is how you optimize the wehnelt voltage.